Right, this is our question paper we are going to work on. November 2009, paper 2. That's our question paper there. Simplify 8 minus 24 divided by what. So that's our question paper number 1. For number 1A, we are going to simplify. Right, so we are to simplify 8 minus 24 divided by 6 plus 3 times 4. Right, to simplify this, we are going to use our acronym BODMAS. So you can either use BODMAS or BOMDAS. Either way, so it's correct. Right, so we are going to simplify this. We don't have brackets on our expression, or we don't have it on our expression, but we have division. So for this is brackets of division, multiplication, addition, and subtraction. So for division there, we are going to divide this part. So we remain with 8 minus 24 divided by 6 is minus 4. Then we have plus 3 times 4. Next is multiplication. So we are going to multiply the 8 minus 4 or plus 3 times 12 is plus 12. We move on to addition. So it's 8 minus 4 plus 12 is plus 8. So 8 plus 8 is 16. That's our solution there. Then we move on to 1B. Right, 1B reads expand 1 minus 2x. So it's 1B. Sorry, 1B. Expand 1 minus 2x multiplying by x plus 3. X plus 3. So to expand this, this 1 minus 2x should multiply everything in this bracket. So everything in this bracket should multiply in everything in that bracket. So to do that, we have to break this bracket. 1 should multiply everything there, minus 2x should also multiply everything there. So we have 1 multiplied by x plus 3, then minus 2x should also multiply x plus 3. Right, then we can now multiply 1 by x is x, 1 by plus 3 is plus 3, minus 2x by x is minus 2x squared, minus 2x times plus 3 is minus 6x. Then we collect like terms there. If you look closely there, we have terms in x, so they can simplify. So we start by writing the highest power of our variable there, so it's minus 2x squared, then collecting like terms plus x minus 6x plus 3, a term without x. Right, remain with minus 2x squared plus x minus 6x is minus 5x plus 3. So we have expanded our brackets there. Then we move on to 1C. Right, 1C. So 1C item 1 reads find the lowest common multiple of 15y squared, 25xy cubed, and x cubed minus x squared. We have to find the LCM, the lowest common multiple. So to find the lowest common multiple there, we expand this 15y squared as a product of its factors, and this is a product of its factors. So we are going to have 15y squared being equal to 3 to the power 1. We are going to express it in index form. So it's 3 to the power 1 times 5 to the power 1 times y squared. Then 25x y cubed is equal to 5 times 5, 5 times 5, which is 5 squared, times x times y squared. We are expressing the products in index form. Then we have x cubed minus x squared. This is equal to sorry, I'm going to use a red marker there. We are going to have x squared multiplying x minus 1. Right, so we have expressed those three as products of their products of their factors in index form. So the lowest common multiple, we are going to collect every term, but we are going to collect where it has the highest power. So for example, we have our 3 there. We search for any 3 there. In our expressions, we only have that 3 to the power 1. So we are going to write 3 to the power 1 multiplied by 5 to the power 1. We are going to look out for 5s there. We only have 5 to the power 1 and 5 to the power 2. So the highest power is, this was for this, the highest power is 5 squared. We move on to y squared. We have y squared. Right, so the highest power is y squared. Then we move on to x. We have x squared. So it's x squared. Then we have times x minus 1. So the lowest common multiple is 3 times 5 squared, which is 75 y squared. Sorry. This is y cubed. So we have y cubed there. That's the highest power. Y cubed. So this is y cubed. X squared times x minus 1. That's our lowest common multiple. Then we move on to C item 2. C item 2 reads, evaluate logarithm of, we are going to evaluate the logarithm of 81 to base 9 times the logarithm of 2 log 8 to base 4. Right. The logarithm is just the same as, it's just a word which is the same as the power. So we are to find, if you are asked to evaluate this part, you are to find the number which, if we raise 9 to that number, we get 81. That's what this statement means. This statement means that we are going to find a number which, if we raise 9 to the power that number, we are going to get 81. So 9 to the power 2 is equal to 81. So the logarithm of 81 to base 9 is 2. Right? Times this one. If we apply the principle of logarithm, p to the power x, sorry, the logarithm of p to the power x is just the same as x log p. So we are going to raise that to the power, sorry, that 8 to the power 2. So it becomes the logarithm of 8 squared to base 4. This becomes 2 times the logarithm of 16, 2 times the logarithm of 64 to base 4. Then 64, we are going to simplify this part the same way we did with this part. Right. So it's just the same as 2 times 4 to the power 3 is equal to 64. So we raise 4 to the power 3 to get 64. So the logarithm of 64 to base 4 is 3. This becomes 6. Or alternatively, we can use this method. The logarithm of x to base x is equal to 1. Take note of this. Right. So we are going to express this logarithm of 81 to base 9. Log 81 is just the same as 9 to the power 2 times this simplifies to log, applying that principle, log of p to the power x is equal to x log p. So we are going to have the logarithm of 8 squared to base 4. Then this, applying this principle, we are going to have 2 log 9 to base 9 times, this becomes 64, so it's log 64 to base 4. This becomes the logarithm of 9 to base 1 to base 9 is 1, applying this principle. So we are going to have 2 times the logarithm of 64 is just the same as 4 to the power 3. So applying this, we are going to have 2 times 3 log 4 to base 4. This becomes 1. So we are going to have 2 times 3, which is equal to 6. Right. So that's our number 1 for November 2006 Zimsec O-level examinations. Thank you.